Hello, my name is Eduardo. I'm an incubation engineer MLOps here at GitLab, and I've been working for a little bit on machine learning experiment tracking, on incubating this feature on GitLab. And today I want to talk about a little bit, not really a demo, but an overview of this project. What is the reason? What is that I'm doing? Why am I doing? How am I doing it? What are the next steps? So to get started with machine learning experiment tracking, I'm going with the assumption that we don't know what is experiment tracking. So the first step is, what is experiment tracking? What is it that I'm trying to create over here? A machine learning model is often seen, for you to replicate a machine learning model, you often need three pieces of information. One is the code that generated the machine learning model. Second is the data that was used to create a machine that was passed through the code. And three, the hyperparameters, so the configuration of both code and data and environment. So with these three components, we have a machine learning model. Now, when a data scientist is working, something that happens often is that we don't know what is the best hyperparameter for the specific code and data. So what we do is we do something called hyperparameter tuning, where we try a bunch of different hyperparameters on the same code and on the same data, and each of the hyperparameters will generate a specific model candidate. And then we compare what is the model candidate that performs best, and we go on with it. An experiment in this case is a collection of very different model candidates that are measured according to that they are comparable. So for example, they are comparable based on the model metrics that they perform. They are a collection of candidates trained on different code, on different data, on different hyperparameter sets, but that are comparable in some way or another. And experiment tracking is a registry where you save all of these experiments, right? So this is what we're trying to build over here. So a data scientist is working on their machine, or is it running on the CI, and they can store all this metadata about their experiments, about this model candidates that they are creating, these artifacts that they are making, into GitLab. How we are implementing experiment tracking on GitLab. So the largest player, the largest open source player over here is MLflow. MLflow has a really good client. So the code that goes into the data scientist writes to save information into MLflow is really good. It has a lot of features. It has a large user base. It is open source. It has a large number of integrations of other tooling that integrates to it. But it doesn't really provide support for authentication or any of the corporate expectations of a tool to be used. So authentication, user management, all this kind of stuff. It needs setup. It needs deployment is another tool that you're deploying internally. So you need a platform engineer that will work on publishing this either in Kubernetes or whatever, and setting up where it will store the artifacts and everything else. And another issue is that it's siloed knowledge. It's the information that is on MLflow. Sure, you can access through an API, but that's extra effort that you need to put. So the knowledge stays a little bit solid. The information stays a little bit solid in it. How are we approaching this then? We have a few North Stars here that we want to work about. One, we want to create an experience that there's zero setup needed. If you have GitLab, it will work for anyone that has GitLab. For the data scientist that already has MLflow or wants to use MLflow, minimal to zero code changes. So their code should just work either on GitLab or MLflow. It doesn't really matter. Third, leverage the GitLab platform. We can build a feature, but we want to go beyond that. We want to use this feature to inform the other stages of the DevOps lifecycle and want to use information from the rest of the DevOps lifecycle to improve the feature itself. So it's not something apart, it's part of the GitLab experience, it's part of the DevOps experience for the data scientists. And more on the technical. So how we are approaching this, how are we making sure that we're following up these North Stars? MLflow is composed of two components for this case. One, it has a client, which is the code that goes into the data scientist code base, where they write, okay, I want to run this experiment and save this name, blah, blah, blah. And there's the backend, which is where the information will go. What we're doing here, we are replacing the backend with GitLab. So by just switching the URI on the MLflow client on the code that they're using or environment variable, instead of pointing to MLflow, pointing to GitLab, it just works. This is where we want to be. Create a drop-in replacement for MLflow backend within GitLab. So the positive side is that, one, if the user has GitLab in their organization, or if they use gitlab.com or whatever, they automatically have experiment tracking. They don't need to set up a different service. They don't need to set up anything. It just works. Second, it's easier to integrate across the platform on our side. So I don't need to be calling an API to fetch information. For example, if I want to display the candidates that were created through NMR, I can have this information already on the GitLab side. I can already prepare the data model and everything for this use case. It's a lot easier for us to work with. There is zero additional setup necessary to deploy. Like I said, it just works. There's no platform engineer help. It's just about setting up. We have authentication by default here. So by leveraging project and group user management, we already give users automatic access to authentication and user management. For the data scientists, they don't need to change anything at all in their code base. The only thing that they need to do is change the URI and pass a tracking token so that they can access GitLab instead of MLflow. The downsides, though, is that we need to keep API parity over time, and we'll have to implement the UI on our side. So we cannot leverage all the great UI that MLflow has already built. We need to implement that on our side. So those are the two biggest disadvantages. But how far are we on this? I have a video over here that shows a little bit of an example. So on the right side, I have a training code. On the left side, I have GitLab working. I'm not going to go through this video. I have the link over there. If you want to watch, I'll link below as well. So at this point, we can already use GitLab as a drop-in for a MLflow backend. This is already possible. We already have implemented the necessary endpoints, the minimum UI necessary for this to work. It already saves the artifacts into GitLab itself. So if you log artifacts through GitLab, it will save on the MLflow. It will save on if you log artifacts with MLflow, it will save on GitLab using the package registry. We are currently dogfooding the MVP. So our data scientists are testing this out, pointing out the failures, requesting features or improvements, and I'm working on to iterate on those. And what are